Hey, thanks for watching. I'm Ben. I'm the founder of GCP Study Hub, and this video is a recording of a live workshop that I did about AI agents on Google Cloud. If you want to learn more about AI agents on Google Cloud, you can check out the link in the description. I actually published a course about AI agents on Google Cloud, and to my knowledge, there is no other course like it out there right now. And I'm going to be putting out more content about AI on Google Cloud. Essentially, over the last 2 years, I've been mainly focusing on certifications, Google Cloud certifications, and putting out content about that. I'm still going to do that, but there's been a lot of demand for more hands-on content and courses, especially around AI. So this is kind of the beginning of a new part of the journey for GCP Study Hub, and I'd love for you to be a part of it. Check it out. Thanks. All right, so thanks for joining. As I was saying, there's going to be kind of a few sections to this. The first, I'm going to go over just like some thoughts on AI agents. I'm going to kind of pontificate a bit. I hope you'll humor me. And I think this is important to frame just kind of the way that I'm approaching the lesson today, and also some material that I'm going to be publishing on GCP Study Hub about AI agents and about just like hands-on AI in GCP in the future. So you kind of understand how I'm thinking about it, what you can expect from me, and just decide whether kind of my philosophy or my approach to things, maps onto what you want to get out of learning more about AI and learning more about GCP hands-on. So I'm going to kind of go through, just like a little bit of an essay on AI agents in the beginning, and then I'm going to kind of I bought a digital whiteboard to kind of architect some illustrations that will hopefully help you understand and demystify AI agents. And then I will go through, so that'll be its own little bit of a discussion, but it's more specific to the topic today. And then I'll go through a hands-on walkthrough in GCP about deploying an AI agent. And I have code ready for that. I'm not going to type out the code in front of you. I have it kind of ready. I'll walk through what it's doing. We're gonna go from essentially building an AI agent from scratch to using the Google ADK, which is supposed to make building AI agents a little bit easier. And then we're gonna deploy that onto Vertex AI agent engine. So you'll be able to see, at least understand at a high level, that like process and where each piece kind of fits in. So that's the plan for today. If you have questions, you can throw them in the chat, and there may be a couple of moments along the way where I will have kind of pauses because I'm waiting for the agent to deploy, for example, and I'll address some questions then perhaps. And then at the end, I'll go through the written questions, and if any of you want to get on mic and ask questions live, we can also do that. But the live questions, I'd appreciate not being interrupted as I'm going through the actual webinar material. Okay. All right, so let's get into it. So AI agents on GCP. And I am going to, as I said, just first share some thoughts on this. I'm going to be a little bit opinionated. I hope you can appreciate that these are my honest thoughts. But to frame things a bit, it's no secret, just like why are we here today, right? It's no secret that generative AI is one of the fastest growing technologies ever, and many are predicting that it will revolutionize many industries. This is why you're here to learn about it. The transition from chatbot to actual integrated business tool is still early, right? And one of the current manifestations of this effort to actually make it useful, to actually integrate it into business processes, is AI agents. And before we dive into that, I just want to kind of take a step back. Until now, most of you probably got memberships on GCP Study Hub because of the Google Cloud certification courses that are on there, one or multiple of them. And that is what I have been focused on until now, right? The philosophy informing these courses has been to teach for understanding, not just memorization, to eliminate fluff and irrelevant content, but still make the courses comprehensive. And this underlying belief that really anyone can pass with the right guidance, the right content. And as I said, while we were just chatting, or I was just kind of chatting to the ether in the beginning, the plan is to continue publishing certification courses. I'm getting some help with that. I expect the quality to be just as good. However, it's clear in talking to you guys that the community needs more practical guidance on technology as the landscape changes. I'm using this kind of generally because I think there will be things not just related to GCP that we go over as we embark on this kind of new journey of hands-on practical stuff, but really it will almost always have kind of one foot in the door of GCP and really focused on the Google Cloud ecosystem. One of these is obviously AI, right? And I want to emphasize that the same principles I think apply here. I want to teach for understanding, not just memorization. I don't want to include fluff or irrelevant content in the courses or webinars that I do about this stuff. And I truly believe, and this is what I'm going to get into a little bit more in a second as well, that anyone can understand AI with the right guidance and the right clear explanations of things. So I'd like to share more about why I feel so strongly about this. And in doing all of the research that I've been doing about AI and about AI in Google Cloud, and honestly, even just in consuming content online about AI, I get a bit frustrated with the way that people talk about AI and AI agents in particular, because that's what we're talking about today. A perfect example of this actually is Google's own definition of AI agents. So let's take a look at this. Google's definition of an AI agent. Google defines AI agents as software systems that use AI to pursue goals and complete tasks on behalf of users. They show reasoning, planning, and memory, and they have a level of autonomy to make decisions, learn, and adapt. So if you're like me, you read a sentence like this and you immediately feel some level of discomfort because of all of its all the things you don't understand, right? What does Google mean by reasoning? What does Google mean by planning? What does Google mean by memory, autonomy, making decisions, learning, right? These terms kind of imply a personification of the agent, and it makes you wonder what's really going on here. And something I kind of resent about this is that statements like this are kind of designed in such a way that if you don't understand it, you blame yourself instead of the explanation. It's honestly almost a form of gaslighting at times. I feel that way. The terms feel important and scary. They promise capabilities that also naturally and understandably induce anxiety, about what this technology is, where it's going. Because the implication is that these agents, these systems are getting closer and closer to replicating or replacing the capabilities of a human. And so the imprecision of the terms and the way that we talk about AI, I think, leads to a lack of understanding, which leads to the assumption that the technology is leaving you behind, or if it hasn't yet, it's going to, or if you don't, learn this technology, then you will be left behind and it's your fault. And I am kind of here to tell you that it's not your fault, or at least that there's more I think that you can do about this than you might assume. And I assume that some of you are at least amenable to that idea because you're here today to learn about it. But I think it's kind of a combination of marketing, people riding the hype train, nobody wanting to look like they don't understand what's going on. And I think the path out of this anxiety is to truly engage with the technical details of these systems. Engaging with the technical details allows you to distinguish hype from truth. It allows you to formulate your own opinions. It allows you to develop a vision for where the technology is headed, how you can use it. It reduces the anxiety you have that is the result of this lack of understanding, right? So when you do that with AI agents, you start to realize actually how accessible they are. They're powerful tools, but they are not magical, right? They don't have special brains with these special capabilities beyond the models that we've already been using. And if you don't know why, I will show you how today. And yeah, engaging with the technical details. I basically said this in the last slide in my notes. I'm going to skip that. I want to be clear about what I'm not saying. I'm not saying that AI agents are not powerful. I'm not saying that they won't come for your job. I can't promise that. Nobody knows. I'm also not saying that I know every technical detail about these tools or where they are headed, how they will evolve. What I am saying is that I think in the research that I've done in the lead up to this webinar, I think that very few people are taking the time to truly understand them at a technical level. And this creates an opportunity for you. A way I like to frame this is like very few people are learning how to cook, and a lot of people right now are instead learning recipes, right? They're following templates on Claude Code. They're following templates on Innate-In. These kind of no code, low code, drag and drop interfaces. They're copying people's prompts. And these kinds of approaches lead to maybe quick wins. But the question you can ask yourself is, okay, what do I do when a client asks for something new? What do I do when I'm working at my company and we come across a scenario that we haven't before, that these templates don't address, right? What do you do when the recipe doesn't work? People are learning recipes right now, as I like to put it, that are making potentially some quick money for them. But eventually, I think they will all be line cooks competing on price. They will be basically automation freelancers because they're focusing on the low hanging fruit. So I think it's worth asking yourself as you think about this technology, where do you want to be? Do you want to be someone implementing recipes, or do you want to learn how to cook? Learning how to cook, I think, is what will allow you to differentiate yourself for the long term. Extending the analogy, it means that you understand the principles. It means you understand heat, timing, flavor, presentation, cooking technique. You can open a fridge, you can be presented with a bunch of ingredients and make something good. You can taste a dish, you can know what's wrong with it. You can invent new dishes because you developed an intuition for the food and for cooking. And, in this case, for the technology, you understand what works and why. I think this has led to this approach that, I've seen a lot online has led to a few consequences here, a few effects that I want to name. So a lot of people are focusing their efforts on teaching and learning coding agents and no code agents, right? So what I mean by that is people are focusing a lot of their effort on agents that can code or on these no code like agent building tools, right? Very few people are focusing on other types of agents or building other types of agents and other ways of building agents. Not that nobody is, but very few people are. Very few people are able to debug and fix agents. And that's kind of a consequence of number one as well. Almost nobody is teaching or learning evaluation of agents. And very few people, this is really the opportunity that I see for us here. Very few people are teaching on a cloud platform or learning agents on a cloud platform. And I think this is where enterprises will want to be in the future, right? Very few people are deploying an agent to Vertex AI, not just GCP, but AWS Bedrock, Azure's version of this. I forget what the service is. With managed sessions, memory, tracing, logging, IAM, all of that, right? People learning this, they have very little exposure to how agents will work inside cloud infrastructure, which is probably where most serious organizations will run them in the future. They're focused on, again, Claude Code, Innate-In, Make, Claude managed agents. That's where most of the content online is focused right now. And I'm not saying it'll stay that way, but I do think that there's a big piece that's kind of missing. And I kind of aim to at least fill that gap for Google Cloud. So what does learning to cook look like? I've been using this analogy. What does it actually look like, right? So it includes many things, but it includes things like what's on the screen. It includes understanding that a tool call is just the LLM generating JSON and that your orchestrator is what executes the function. Again, nothing magical going on there. It makes so much sense once you see what's going on. Understanding that a session and agent engine on Vertex AI is a conversation history that is just persisted to a database and it is keyed to a user. Nothing magical. Understanding the limitations of the ADK and what you have to write yourself with raw API calls. Understanding how to run robust evaluation of agents, which again, I don't think people are really teaching. Understanding tracing and logging in Vertex AI so you can find the problem, which again, a lot of these no-code tools that people are focused on right now don't really have. Understanding how to map business requirements to technical requirements. And so we're not going to cover all of this today, but in thinking about what I can offer the community, these are the things that I think are important and that I plan to cover going forward. So thanks for humoring me, allowing me to pontificate a bit. I shared all of this kind of in order to set up my philosophy and approach to teaching you this stuff. My goal is to teach you to be the chef, not the line cook. And with that, we're going to get into what agents actually are. All right, so can you still see my screen? Oh, I appreciate all the claps. Can you still see my screen? Okay. So I hope this works. I'm not the best artist, but I do think that if I can get good at this, this will really like open up a new way of like instructing. And it'll also mean I don't have to like put in hours ahead of time into creating diagrams on PowerPoints, although like that is still worth doing in some cases, and definitely with the certification courses, because I want those to be polished. But I'm here to basically explain a few things before we go into actually using Cloud Shell and GCP to make an AI agent. Okay, so first I'm going to cover just, let me make this thinner. I'm going to cover what agents actually are. All right. I'm going to present to you a very simple equation. And you'll be like, is it really that simple? And you'll see that it is. What agents actually are. An agent is an LLM, a large language model, plus tools, okay? And tools are basically just Python functions or MCP servers, Model Context Protocol servers, plus a loop. And if any of you have experience coding, what I mean by loop is a loop, a while loop. And this is the fundamental principle that you should take away from our webinar today. Okay? So there is nothing magic going on here. An agent is what you get when you give an LLM access to Python functions or MCP servers, which are basically just a standardized way to give an LLM access to some kind of external tool. You tell the LLM what that is, what the tools are, and then you basically put the function calls in a loop such that it keeps calling tools until the LLM, quote unquote, decides that it's done. And what I mean by that is that the LLM, instead of continuing to return function calls, it will just return a natural language response, and then the loop will break. All right. So that is the equation that you should memorize for our discussion today. And now I'm gonna draw a basic architecture of what this looks like in a little bit more detail. All right. So when you use an agent, basically you have the user, all right, and the user sends a request down to what's called the orchestrator. The orchestrator the orchestrator basically is connected to both the tools and the LLM. Okay, so on the left here, let's put our tools. My hand is like shaking because I'm like nervous, and this drawing is new for me. But we'll get through this. Okay. So let's say tool 1, tool 2, and tool 3. But this could be, you could have one tool connected, you could have 15 tools connected. And so all we do is we take these tools, okay, and we describe them. And we put those descriptions in the orchestrator. And so then the orchestrator can take the request from the user. Okay, so the orchestrator takes the request, and the orchestrator has access to the descriptions of the tools. Yes, Dennis, the recording will be made available after. Good to see you. Thanks for joining. So the orchestrator has access to the request from the user and the descriptions of the tools. And so what does this allow the orchestrator to do? That allows the orchestrator, over here we have our LLM, all right, and this can be like Gemini, it could be Claude, one of the Claude models. It could be GPT, right? Really, any LLM. And so the orchestrator, because it has descriptions and the request from the user, the orchestrator can send both of those together as a query to the LLM. All right. So we've got request plus descriptions of the tools. Okay. So the LLM, think of the context that the LLM has now. The LLM knows, okay, this is what the user wants, and these are the tools that I have available. I can use tool 1, I can use tool 2, I can use tool 3, and these could be anything that you can do in Python, anything that's available through an MCP server. And so then the LLM has taken in text and it returns text. And that text, let's use a different color for this part of the flow. So that text, if it wants to use one of the tools, will be a structured JSON tool call. Okay? So it's basically just a way of telling the orchestrator through text, hey, I want to use this tool or this combination of tools, and I want to use it with this data, right? So this input data based on what I know about what the user wants and the descriptions of the tools that you told me exist. Okay. And so then the orchestrator can make a call to the tools. So tool call. So the LLM actually isn't even seeing the tools directly. The orchestrator is doing the translation. The orchestrator is Python code that either you write or you write with the help of one of these frameworks that makes it easier, like the Google ADK, right? So the orchestrator makes a tool call and then gets back the result. Okay, so tool output. Tool output. Okay, and so the orchestrator basically, receives the tool output, and within the orchestrator as well, is a loop. I'm going to use a different color for this as well. And I'm going to put this in big letters because I think this is a very important part. And the loop basically says, okay, we're going to keep doing this. We're going to keep doing this until the LLM no longer returns a JSON tool call. Okay? And the orchestrator is going to keep sending the LLM not just the request and the descriptions, but also the output of the tools that that the LLM requested as part of its response to the orchestrator, right? And so then with each query to the LLM, you have the request and the descriptions and any tool outputs. And so every time the orchestrator makes a new query to the LLM, it sends this entire message history. So this is kind of what I mean when I say I really don't like how vague the popular ways of talking about LLMs about AI agents is, because when Google says agents have memory or they exhibit memory, they actually kind of don't when you think about it. Because what has to happen is, and this happens every time you query an LLM in your browser as well, or when you're using, Claude Code or something like that. Every single time the message history is sent with the new request. So the orchestrator is sending to the LLM not just the output of the tools, all right? But it is also sending to the LLM the request that was the original request from the user and the descriptions of the tools. And so every single time, the orchestrator is just adding more tool outputs until the LLM no longer needs the tools. All right. And how does it know that? Again, it's not magic. It's pretty simple, at least to understand. I'm going to use red because this is when it stops. Things stop when the LLM makes not a JSON tool call, but a natural, let me try to write this clearly, a natural language response. Okay. So once the orchestrator receives back from the LLM just the response in natural language and not a structured JSON tool call, then the orchestrator just sends that to the user. So the user doesn't see all this. The user doesn't see the tool calls. The user doesn't see the JSON tool call from the LLM. The user doesn't see everything that gets sent to the LLM. The user just sees, I'm going to just call this natural language response, NLR. And so from the user's perspective, the user asked a question or made a request and just got back a natural language answer. But this is how it was constructed. All right. So again, it's not that these tools aren't powerful, but where is the magic? The magic really still is in the model. I mean, these are very powerful tools. But when we talk about AI agents and we talk about giving them autonomy and we talk about them having memory, right? What do we really mean? Understanding, this is my thesis statement today, right? Understanding the technical aspects of these systems, really being willing to engage with that is what appeases that anxiety, is what demystifies them. And so that this is kind of the approach that I think we should be taking to learning AI agents. I almost guarantee you that people who are learning them, online right now, most of the time are not really learning how this works. And I think if you do, you will, and if you apply this approach going forward, you will have a leg up and an advantage on other people. Okay. So that covers that. And now I want to, before we get into GCP, the GCP like hands-on demo, I'm going to show you the agent stack on GCP. Just kind of draw that out for you. Okay. And so let's see. Essentially, we're going to have the GCP agent stack, or let's call this the agent ecosystem. Agent ecosystem. And there are kind of multiple components to this, right? So obviously we've got the Gemini models, or really just any model that is available through the APIs that you're using. But Google's models are the Gemini models. But Google makes available not just Gemini models, but other models as well on Vertex AI. So we've got those. We've got also the Google Gen AI SDK, okay, which is probably the most kind of bare, unless you're literally doing raw API calls, is probably the most kind of bare bones approach to interacting with these models. Google Gen AI SDK. And then we've also got the Google ADK, which is essentially Google's framework, and it's open source, and it works with more than just Vertex AI. It is Google's open source framework. Here, I'll circle this and I'll say Google's open source framework for building AI agents. So it basically makes it easier to build AI agents with code. Okay, so it's not no code, it is code, but it's a framework. So it abstracts away some of the things that you would be doing with raw Python, right? And then we've got, this is worth mentioning, although I don't think we're really going to use it. Definitely not today, but the Google A2A, or agent to agent protocol. And this is Google's, wow, my Google Home just started talking to me because I said Google. Let me turn it off. That's actually so funny. That has happened before. I've literally been creating course lessons before, and because I said the word Google, my Google Home thought I was talking to it. All right. The Google A2A protocol is a standard way for agents to communicate with each other. Okay, so this may become more popular in the future, so I think it's worth mentioning, but it really hasn't kind of gotten the fanfare and the attention that Google expected. People are not really using it, but people are using the Google ADK. It's very popular, and it's kind of probably the most important thing to learn in terms of how to build agents right now. And then over here, we've got the Vertex AI stack. So let's call this Vertex AI. And this entire suite that I am going to illustrate on the slide, on the screen, is what's known as Agent Builder. Okay? So Agent Builder is not actually like the single feature that you build agents with. It is a collection of features in Vertex AI. All right. And so we've got a few things here. We've got, let's see, I'll use a different color. We've got Agent Designer. And this is the no-code approach, drag and drop. We've got Agent Garden. Agent Garden is like Model Garden, but for agents. So it's got templates and pre-built agents that you can use. We've got Agent Engine. And Agent Engine is the managed runtime. Managed runtime for agents. All right. So you deploy your agents to Agent Engine, and then you can use them in apps or UIs, or kind of as, you know, its own service API. Agent Engine is where you do that. And then we've got Vertex AI Agent Builder Tools, which is basically just, I looked into this, it's basically just the, what's it called? The Cloud API. Let me look at my notes for a second. The Cloud API Registry. Yes. So this is something that Google actually had before. They kind of wrapped it up into MCP format, and they made that available in this feature called Tools in Vertex AI Agent Builder. Okay. And then we've got grounding and RAG. So we've got a few. I'm going to use a different color for these since they're kind of one category. We've got Vertex AI Search. We've got Vector Search. And we've got RAG Engine. And so these are three different ways of basically implementing RAG on Vertex AI. Vertex AI Search is probably the most common one that you're going to use. RAG options. And but you can also do Vector Search or RAG Engine. They basically differ in terms of how abstract they are and how much you have control over things versus how much Google kind of handles for you, right? Most of the time you're going to use Vertex AI Search, but if you need more customization, I think Vector Search is the most customized approach, and RAG is kind of somewhere in between. Okay, so this is the GCP agentic ecosystem, right? And so when you are building agents, you have a few different ways to do it. You can use the GenAI SDK if you really want control at a detailed level through Python. You can use the ADK if you want to use a framework that makes it more convenient for you. With the ADK, you can use Gemini models, but you can also use other types of models. And then in terms of where to deploy it, you would typically deploy it on GCP to Agent Engine. And Agent Designer, I didn't really mention Agent Designer as a way to build agents because honestly, it still is a bit janky. I tried to use it and I kept running into errors, and I was pretty confident that I was not doing anything wrong. I think it just got released like a few months ago or something, so it might still be in preview. I don't recommend using Agent Designer right now. I'm excited for when that becomes more available, and that might be kind of a convenient way for people to build agents. But that would put, if you're using that, that would kind of put you in the category of people who are currently using some of the things that I mentioned earlier, like some of the no-code approaches, like on Inaden. That's where a lot of people are focusing their effort. But if you're willing to engage with the ADK, you'll understand things at a deeper level, and you'll be able to build more reliable agents, I think. So if I were you trying to build an agent on GCP, I would use the ADK plus Agent Builder. And if you need RAG, I would use Vertex AI Search, or at least that's how I would start. So just looking at my notes here. Yeah, so one thing about Agent Engine, because we are going to look at this in the demo as well. One thing that's great is it has sessions which persist the conversation history between the user and your agent in a database. So someone can talk to your agent on one day and then talk to it again on a different day. And the agent has that full message history. It can also extract and store facts about a user across conversations. It also has tracing, which lets you see the exact sequence of LLM calls, tool calls, inputs, outputs. We'll look at that as well. If you are, if you're using some of these more managed approaches or no-code approaches, you don't really get that level of understanding about what's going on, right? And then obviously you also get logging. You get integration into the cloud logging and monitoring on GCP, which again is one of the reasons why I think these companies that are going to be using agents going forward are really going to prefer to do this on a platform like Google Cloud or AWS or Azure. You also get the auto scaling of compute with Agent Engine that you would get if you had deployed something on like Cloud Run, for example. You get to choose the minimum and maximum number of instances, as you guys are probably familiar with other services on GCP. So it's just, it's really convenient in that way. And then you can also control access to the agent through IAM in the same way that you would on something like Cloud Run, right? Like a Cloud Run endpoint. Okay, so you get the idea. We've got the Gemini models, the GenAI SDK at a low level, the ADK at a higher level, the A2A, which is a protocol for agents to communicate with each other, which is not really taken off. And then we've got the Vertex AI stack as well, the Vertex AI Agent Builder stack. Cool. So now let's go through some code examples. How you guys doing? Okay so far? Cool. All right. Oh no. Lost the connection to Cloud Shell. I'm going to do this in Cloud Shell. I'm going to do this. Yeah, I'm going to do this in Cloud Shell. You could really do this, on any terminal. You could do this locally. I think Cloud Shell is super convenient for these kinds of demos. And essentially, I have an agent that I have two ways of building. One of them is the most basic bare bones way using the GenAI SDK. The other one is using the ADK. So I've got two directories here for this workshop. And then when we build the one with the ADK, when we go through the code and understand just kind of how it works, I'm going to deploy it to Agent Engine. And then we'll also see how we can access it from Agent Engine. So because my Cloud Shell session had to reset because it took so long, I need to do a little bit of setup real quick. I did not expect that. So I'm just, this is maybe a good actually part of the lesson. I'm just setting my project so that I don't need to pass that in every single time. And I'm going to just make sure that the dependencies are, I could share the code. I didn't plan to do that, but I could share the code. Yeah. That's a fair question. Okay. So, we want to make sure that all the dependencies are installed. So I am installing the GenAI SDK and I'm installing requests, which allows us to build the tools that we're going to build. And then also the ADK. So those are already satisfied, so no problem there. And all right, so first I'm going to look at the Scratch agent, the agent that we're building from scratch. And this is essentially one file that we care about here. This is a lot of code, or at least a lot of code to understand in a few minutes. So let me go bit by bit and try to make sure that you at least understand what this is doing before we abstract it away with the ADK. So first we've got the tool function. this is our tool function. Essentially what this agent is going to do, it's going to be able to answer questions about books. Okay, this is a simple agent. And so the tool function that we have made available to it is just an API, the Open Library API that allows you to get data about books. Okay, and so there's no AI involved in this function. It calls the Open Library API. It returns a cleaned up dictionary. We've got the type hints up here and the description, the doc string, which are important because later on the ADK, and this is something the ADK does automatically, will actually look at these and it will construct the description for the LLM that you're using, right? So, all those years when you maybe learned Python and were told that you need to have very clear descriptions of your functions, well, it actually matters now when you're when you're building agents, or at least the ADK. We've got the tool definition down here. So this is where you describe the function in a JSON schema. We're doing this ourselves right now because we're not using the ADK, but again, the ADK would do that based on your function description or doc string. And this is basically the schema that the LLM needs to follow, right? So the LLM reads this to decide if the tool is relevant and the parameters with their types. You're basically writing API docs for the LLM. This entire block disappears when you use the ADK. So I want you to understand what it would look like if you built this from scratch versus using the ADK, all right? The function registry. So the function registry is very small for us right now, but what you would, you would have potentially an entire list of all the functions, all the tools that you have available, that you are making available to your agent here, but we just have one. And this maps the function name string to the actual callable function. So, most of the time they're going to be the same, but you actually have to map them. This also disappears with the ADK. Now the agent loop. Okay, so this is where our code basically turns the model into an agent, right? Because the agent, because of this loop, gets to keep making tool calls until it's satisfied, until it returns not a tool call, but just a natural language response. So I'm not going to go through literally every piece of this, all right? But it's essentially, it's a while loop that sends the message history to Gemini. We're using Gemini. It checks if the response is text or a function call. If it's text, return the text. If it's a function call, do all this stuff. And it either returns the text or executes the function, and it continues to loop. The function args unpacks here we go. Unpacks the dictionary into keyword arguments. Then the function results go back with the role equals user, because in the Gemini API, everything that isn't model output uses the user role. That's down here. And the message history continues to accumulate, right? Each iteration sends the entire message history, so the model has the complete context. It feels to you like the model has memory, but actually the model needs to be reminded every single time of what the history is, right? And this is what makes it an agent, okay? And then this is us just running it. All right, so we're gonna just run this, and essentially the question that we are going to ask is, tell me about the book Dune by Frank Herbert. All right, and I'm gonna clear this. All right, so yeah, I had to reset this. So Python agent.py. Okay. So we'll just see us get we should see the result from the agent calling the tool. Here we go. Sorry, I had to set that up again. I had set this up, but the Cloud Shell times out. So the tool call, we can see here, it calls search books with this as the input to that search books function. We get the tool result. All right. We get the data about the book. And then we get the agent actually returning a natural language response from this tool result. Okay. Dune by Frank Herbert was first published in 1965 and it has 120 editions. Let's see what happens when we ask the agent something like completely irrelevant. All right. So let's change this to what is the capital of Brazil? And let's just see what it does. So it says, I cannot answer that question, with the available tools, right? So this tool description says nothing about geography. And so this is why we get that response. So you can imagine how you can use the tool descriptions in addition to the system instructions for the agent to control what the scope of appropriate queries are that your that your users can ask and how to handle them, right? So just a simple example of that. Now let's try to get the agent to do multiple tool calls, and let's see if we can see them. One difficult thing about demoing Gen AI demos is that you never really know. Oh no. Did I accidentally do dictation? I think I did. Okay. Okay, please ensure that the function response parts is equal to the number of function call parts of the function call turn. Okay, what happened here? I want to jump in here real quick because I was able to look at what actually happened with this error after the webinar. And essentially what happened is the loop that we had created, or that I had created, that was customized because we weren't using the ADK, we were using the Google Gen AI SDK, was only programmed to look at the first part of the request. And when two books were requested to be looked at by the LLM, the loop wasn't able to handle the second one. And so essentially there was a mismatch between what was being requested and what the loop could handle. So this was actually a good teaching moment. I wish I caught this in the moment because it shows kind of the risk of coding all of that yourself and the advantage of using the ADK. Obviously, there are kind of some trade-offs. Sometimes you do want that level of customizability, but for most cases, the ADK will be what you want to use. And it's in large part because it handles these kinds of things appropriately. If we had run that query with the ADK, it would have been able to handle both of the tool calls, the one for the first book and the second book, not just the first book. Anyway, I just wanted to comment on this. We're going to go back to the webinar now, but to make sure you understand kind of what happened there and that I wasn't just glossing over the error. Thanks. Let's bring this back to tell me about the book Dune by Frank Herbert. And so we're going to take this structure right here and we're going to convert it into the ADK approach. All right. So just to kind of go over this again, the way this works when you don't have the ADK is you have the tool function, you have the definitions which get abstracted away by the ADK later on, you have your registry which you have to specify yourself, and then you also define the agent loop. Okay? And so this is basically like a bare bones approach. You are using the Gen AI SDK, but none of this gets abstracted away. And then when we use the ADK, what we can do is we can make the same agent using the approach that the ADK expects, which I'll walk through in a second. And then we get a little bit more flexibility and functionality in how we actually approach things. So we've got tools.py. And essentially what tools.py does is this is where we define our tool functions. Okay. And again, we've got our doc string here. Nothing changed here. And then we've also got a tool that we're going to define just for the sake of, demo, called get author works, where you can actually specify an author and it'll retrieve a list of the works by a specific author. Again, we're using the same API, but it counts as a different tool because we're actually using a different part of the API. And so now we've got two tools. We're not just using a tool where we search for books. We're using a tool where we actually get the works of the author as well. And so notice here as well that our explicit tool definition is gone. We don't have that here. The function registry is also gone. And our agent definition is literally this simple. Okay, we're calling it root agent because that is what the ADK expects. And we have to import that here. We're importing from agent import root agent. So that tells the ADK to look for this. And our agent definition includes the name, the model, obviously, but that hasn't changed. The name, the instructions. So these are the system instructions. And then the tools that we're making available. So we've got, search books, get author works, and those are defined in tools.py. Okay, let's see if there's anything else. The loop is also gone, right? So up here, we had the while loop that we defined ourself. And down here, when we're using the ADK, that gets abstracted away. So we've got no while loop. The logic of the while loop actually runs internally in the ADK. And if you want to control that, you can, but by default, it does the exact same thing that we had in our agent.py file up here. Okay. So now let's see. I'm gonna actually run this in the ADK web UI. And this is also something cool that you'll see in a second. This is a tool you can use to actually debug your agents. All right, and actually see the trace and stuff. So this is not the agent engine, but this is a very useful tool. And what we can actually do is we can ask questions to our agent in the same way that we did in code up here. And we can see what it would, what the agent would do exactly. All right, so let's try to ask, tell me about the book Dune by Frank Herbert. And let's see what it does. Okay, so we see, let me try to zoom in here so you guys can see. Dune by Frank Herbert was published in 1965 and has 120 editions. There are also 2 summaries of the book, blah, blah, blah. Okay, so, you might be wondering, okay, why are we, if I just asked ChatGPT or Claude or Gemini, this question, I would get a similar response. The point here is this is like our hello world for, agents. The point here is to show essentially how agents work, not necessarily the complexity of the tools themselves. What we can see here is exactly how this was generated. Okay. So if I open up the request, and I can actually see which tools the agent has access to and which tools it used. All right. And I can actually see the trace as well of which calls to the tool, to which tools were made and what data was sent back. Right. So this is super helpful when you're actually developing agents. And if we were to ask, if we were to ask a question that we expect to uh, give us, to use the other tool, we'll probably see that it uses the other tool. So tell me about the books that Ernest Hemingway wrote. Ernest Hemingway wrote the following books. Yeah, so you can see. Oh, okay. Interesting. So it used actually search books, probably because of but this is actually really useful. So this did not do what I expected, but the fact that we have the ADK showed me that this did not use the tool that I expected it to, right? So now I get to investigate that. I get to think, okay, does my tool description need to change? I'm not going to experiment with this now because this is the kind of debugging that you would do. But my point is that maybe my tool description needs to change. Maybe the fact that I used the word books in the in the prompt is what led it to use search books instead of get author works. Let's see if I say get the works of Ernest Hemingway for me. Yeah, okay. So this time it used get author works. So if I was developing an agent, right? If I was developing this agent for like a library or something like that, or a bookstore, um, I would want to use this to debug exactly when and why it's using one tool over the other. So my point is that this tool, this ADK web UI is really helpful for this stuff. Now we're going to deploy to Agent Engine. Okay. So I talked about what Agent Engine is. It's a managed runtime inside Vertex AI Agent Builder. It's like Cloud Run for agents. There are a few different APIs you need to enable, and those should already be enabled. I did that before the session. You also have to create an identity for running your agent, and the deployment kind of fails with a cryptic error if you don't do that. And to be honest, Google's documentation isn't very clear about that. I'm just going to make sure that this is created. Okay. And then you also need a staging bucket so that your packaged code can be uploaded there during deployment. And I have already created this staging bucket. Now, going through the deployment script. So we're using the exact same agent with the ADK that we just created. All right, and this is the deployment script. So I have my project. I have the staging bucket. I'm using US Central 1. You don't need to use that location. And essentially, I'm also enabling telemetry because I want to show you that you can get metrics and tracing on your sessions and requests with Agent Engine, which is one of the convenient things about it. And I think that's pretty much it. Okay, actually, ADK. So what this does is it creates the app in the same way that you would if you used it locally, and then this essentially right here serializes the agent. It uploads it to a staging bucket, and sorry, this part does serializes the engine, uploads it to a staging bucket. In order to create a runtime. This part just creates the client with Vertex AI. Okay, yeah, so I think that's it. And we're just going to deploy this. And as we do that, it'll probably take a few minutes to actually deploy. But what we will see when it's ready, and I am going to just actually let this deploy, even though I already deployed a couple earlier. We'll see a new agent show up here. And it's going to have the same name as this one because this is the one that I created before. But then it'll give us a resource name like this, and then we will use that resource name to then make requests to the agent, like an endpoint. And so then you can imagine how you can integrate the agent into really any other solution. So this is going to take a few minutes. Maybe I'll pause here and answer some questions or look at the questions if there are any. It doesn't really look like there are any questions. Request plus description is in JSON format. Yeah, it is. And so it's all text, and the agent is really it's almost as if you can imagine with one of these models, if you were to tell it with your own, even in just like natural language without it being in JSON format, these are all the tools that you have available, and this is what I want. It would be able to take in that text and decide which ones to call, right? So it's not even necessarily anything special. And that is kind of my point. It's not that these tools aren't powerful. It's that when you really understand them technically, the kind of mystique and scariness of them starts to sort of fall away. All right. Anyone else have any more questions while we wait for this to deploy? If not, that's okay. Actually, well, yeah, I am going to wait for this to deploy because I want you guys to actually see. But there are a few things. Let me just, I'll jump ahead to, let's see. The cases where the correct tool was not taken, what would be some debugging strategy? Yeah, okay, so that's a good question. So here, so you're talking about where I asked it, tell me about the books of Ernest Hemingway wrote, and it gave the wrong, or I mean, it gave the right answer, but it didn't give the it didn't use the tool that I thought it would. So what I would do, honestly, what I would probably suggest doing is understanding, like what I would take away from this is I would understand, okay, there is a region of overlap between these tools that I probably need to be more clear about in my descriptions of the tools and in my instructions to the agent. And this is where I think, again, some of the instruction online around AI agents is not like exactly clear. You do still need to be able to kind of put on your critical thinking hat and say, okay, what am I really trying to accomplish here? And how do I distinguish between all of the tools that my agent has available to it such that it knows very clearly which one to use for which? Or do I really, given my use case, do I really not care that much whether it uses the search books, tool instead of the get author works tool? Because like it got the same, it got basically the result I was looking for. But, let's say, well, I guess let's actually compare these. So I do see, tell me about the books that Ernest Hemingway wrote. Ernest Hemingway wrote the following books. So there are more books actually that were, more books that were given in the second query than in the first. So that would lead me to think, okay, what am I really trying to accomplish with each of them? And I would go back to my instructions. You help users find information about the books and authors. Use search books to find books by title, author, or topic. Use get author works when the user wants to see more books by a specific author. Okay, so I can see where the ambiguity would arise. So I said, use search books to find books by title, author, or topic. And when in the dev UI, when I said, tell me about the books that Ernest Hemingway wrote, it probably interpreted that it probably interpreted that as pertaining to this criteria. Use search books to find books by title, author, or topic, because we're basically telling it to, by author, be able to find the books that Ernest Hemingway wrote, right? So I would probably work on disambiguating these instructions, which kind of leads to an interesting thought, right? Because like you can understand how these, like someone can understand how to wire together these tools, but like if someone is not like there's a basic sort of communication skill that actually has to be exercised when you are building agents. How do I disambiguate between these tools when I'm telling the agent which one to use, right? There's like almost like a writing skill that comes into play here. So let's see. Use search books to find, use get author works when a user wants to see a complete list of works by a specific author. Use search books to find books by title. So let's actually say, you know what, I want to see let's try this again. I'm going to have to redeploy this. Let's just use this exact same prompt and see what it uses. All right. Tell me about the books that Ernest Hemingway wrote. I need the author's ID to look up their works. I can search for Ernest Hemingway to find his ID. Would you like me to do that? Yeah, that's interesting. Okay, so it's still okay. So it's using get author. Oh, actually, this is really this is really interesting. Okay, so what it did multiple tool calls. I'm glad we went into this. Thank you for that question. So yeah, I mean the AI agent can definitely help you write the instructions as well. We used multiple tool calls here, right? So, and it did that in a loop. So we can see that it used search books and then it called get author works. And that's because apparently it needed, the author's ID to look up their works, to look up Ernest Hemingway's works. And I think honestly that's because of let's see. Yeah. It inferred that from the schema for the tool. And I probably don't want, honestly, that to be the user experience. So I'd probably have to tweak that as well. But okay, here we go. The open library author. Yeah, so this is what it did. So again, this is interesting, right? So what it takes for get author works, this might be why it didn't do it last time. But I don't really know. We'd have to spend more time looking at this. But it needs basically the get author works tool takes as an argument the identifier of the author. Right? So that is probably something that we would want to prevent it from asking the user for, like whether it has permission to do that, and just like have it do that, right, in a loop. So we could probably update the instructions to just prevent it from prompting the user to because it doesn't need to ask the user whether or not it needs to look up the author ID. All right, but I'm glad we saw, a situation where it actually called multiple multiple tools. And we can see that it called search books and then get author works and then returned, this entire list. Yeah. Okay. So our agent deployed to Agent Engine. And so now let's actually look at what was deployed. And I'm going to get the resource name. I'm going to go back to Agent Engine here, the script that will allow us to interact with it. And then I'm gonna just kind of make sure all this looks good. And then we can actually use this as it's deployed to Agent Engine. A couple of things I want to point out here. So this is some of the metrics that you get for using Agent Engine. So you can look at the sessions when you actually start using it. And then you can get these metrics as well, which can be really convenient, especially if you have a lot of users with your agent. All right, so we want to, let's see. We want to just run this. And so this is going to make a request to the Agent Engine agent that we have deployed. I specified the project. And then I've specified the agent based on the ID of the agent. Now, this is called Reasoning Engine in the resource name, because actually, like, I don't know if you guys know, but like Google often like renames services, and they don't want to, like, for the sake of backward compatibility, they don't want to actually change it in the APIs. So Reasoning Engine is what it kind of used to be called, and now it's Agent Engine. But that's why you see that there. And so now we can type a question just like we had, in the ADK, and we should get a response. So let's ask the same question. Let's see. Tell me about the book Dune. Yeah. Let's see what it says. Okay. So we see the tool call, we see the result from the tool, and then we see the agent's natural language response. Dune by Frank Herbert was published in 1965 and has 120 editions. Okay. What are all the works by Ernest Hemingway? And if we go here, we should see sessions. Yes. So this is a session that we just created. Check it out. So you can see if you have users using your agent, you will be able to see how people are using it, right? Which is pretty cool. So you can see this being really useful if you have an internal agent, for your business. If you have an external facing agent, you can actually see the sessions and use that to improve the agent. Yeah, so we've got, let's see, we can see the traces here. Check this out, right? Like, you can see the entire trace. This is what's really cool about using Agent Engine. And this is the kind of thing that, again, I don't think you would really get if you were using a lot of the tools that people are using to build AI agents right now. Like even, I don't think Claude gives that level of granularity, and I don't think N8n does. So this is the advantage of using Agent Engine, or one of them. All right, we got our response to our question about Ernest Hemingway as well. So you guys kind of get the point. You could integrate this into a web app, or you could just use it as an endpoint and integrate it really anywhere that you would any other endpoint, and you get the scalability and the management that you typically get from, a managed endpoint or service on GCP. You get, let's see. So if I click on this, I should be able to as well. I should be able to configure it. Yeah, okay, here we go. So you can configure scaling. You can configure the resource limits. You can configure permissions. You can make sure like only certain service accounts or people can make requests to it. These are the details of the deployment. Memory bank, I'm not really sure what that is yet. Anyway, so and this is enabled because I enabled it when I actually in code when I deployed it. All right, so you get the idea. Okay, so I'm gonna stop there, or at least the demo, and see if you guys have any questions. I ended right before 2:30, which I'm proud of myself for. Let's see. How do we know whether a particular use case needs multiple agents and how the root agent coordinates them? Yeah. So I think you can approach this in a couple of ways. I think it depends on the tools that you are actually like hooking your agent up to. But if the tool itself has the flexibility to take multiple different kinds of requests, like for example, if you're hooked up to a BigQuery, MCP server, right? This is probably a common use case for people who are creating agents on GCP. You might not need separate tools for like separate data sets, right? But then you would need to make sure that the agent understands that the tool has the ability to take requests or queries of different data sets, and you would need to specify in the instructions or the description to the agent what those tables are, right? Like the table name, right? So instead of having different tools for different tables, you could have one tool, but then you would need to make sure that that information of the different ways that you want the single tool to be used is made clear to the agent in the natural language description that then the ADK, if you're using the ADK, makes available to the root agent, right? And so then if using a single tool is not enough there, then you would need to create separate tools with separate arguments that it accepts and descriptions, I would say. Now, most of the time, though, you're not necessarily going to have like that. It's not going to, a lot of times it's not going to be that ambiguous, right? Like you might have an agent that's like an internal facing tool that is basically like an agent where people can ask questions about your company's like internal data. And yeah, one of them will be, BigQuery. Another one will be some web app whose like session data you have stored somewhere. Another will be like, another database that you have stored on GCP, and you will just describe to the agent the different kinds of data that are in each of those. And it's like obvious that you would need to use a different tool for each of those because there is no single tool that covers all of those data sources, right? So it's really, the way I would think about it is like, and this is why I think it's kind of interesting to observe that people don't, that like technical skills are not necessarily enough to build AI agents. You also need to be able to understand like how your natural language descriptions of the tools help to disambiguate them for your agent. You basically need to pay attention to whether or not the description as it is gives your agent enough of an understanding of the different ways that it should use a single tool, or if that leads to too many errors or unexpected ways of using that tool, then you would need to separate it out into multiple tools, I would say, and have more control at the tool level, rather than relying on the agent to use a single tool appropriately. I hope that makes sense. All right, thanks guys. Take care. Have a good weekend.